Good morning, afternoon, or evening, and welcome back to Mr. Moore's Algebra class. I hope you all had a great Thanksgiving holiday. I know I did, and I was very blessed to be with my family. Today we're going to continue with functions, and we're going to actually focus in on one type of function, which is called a linear function. Okay, so for chapter 4, we're going to talk all about linear functions, how to write them, how to graph them, how to write equations, how to apply them in word problems, all that good stuff. So when we're identifying linear functions or linear equations, remember, a function is the same thing as an equation. It's a set equation. It's not going to change. And there are three forms of linear equations. We're going to get into this with much greater detail, I promise. But I just want to give you a little first off, what you should expect. All right? And we have three types of linear functions, three forms. First one is called the slope-intercept form. The reason why it's called slope-intercept, and I promise you, I will go over all of this in much greater detail when we hit each specific equation. But for now, it's just a general overview. This M, that's called the slope. We'll talk about slope later. And this B, that's called the y-intercept. We'll talk about that later as well. But just know that when you have a slope and a y-intercept, you're going to be using the slope-intercept form. When you're using the point-slope form, okay, the point-slope form is y minus y1 equals m times x minus x1. M, again, is the slope. And the little x1, y1, that's a given point. They will give you that value, guys. Okay, that's a given point or ordered pair. As you know, that's what a point is. It's an ordered pair. Okay? And the last type is called standard form. And that's ax plus by equals c. I'll explain that a little bit later today. Okay, so these are the three different forms of linear equations or linear functions. Now, why? Well, let's look at some things here. Linear functions are functions where x and y values are not being multiplied to any other variables in the numerator and with an exponent of 1. So think about it. Linear. Negative y equals 4x. Is x being multiplied to another variable? Okay, someone said yes. No, it's not. X is not being multiplied to another variable. No, it is not. Is y being multiplied to another variable? Okay, someone said yes again. What variable is being multiplied to y here? No. The answer is no, it is not being multiplied to another variable. What is the power of y? 1. What's the power of x? So it's linear. We're good. Linear. Not linear. See here how the x is being multiplied to y? That's not linear. That is not a linear equation or function. Here, I have an x, or 4x plus 2y equals 12. Is x being multiplied to another variable? No. What's the power of x? Yeah, when it's invisible, it's 1. Is y being multiplied to another variable? What's the power of y? 1. Okay, and they're both in the numerator, so that's linear. Here, I got x cubed plus y. What's the exponent of x? So that is not linear. Next, y minus 6, bless you, equals 4 times x plus 3. Is y being multiplied to another variable? Is x being multiplied to another variable? Is x and y both in the numerator? Yes, both x and y are in the numerator. And what is the power of both x and y? So it is a linear function. Here, 2 plus x plus 2 over y equals 5. Okay, x is not being multiplied to anything. Y is not being multiplied to any variable. The power of x is 1. The power of y is 1. However, is this in the numerator, the y? So that is not in the numerator. So that is not linear. Sir, Okay, that is not what I said. The question was if division is occurring. No. X divided by 3 plus 2y equals 5. That is linear because x is in the numerator, y is in the numerator, x has a power of 1, y has a power of 1, and x is not being multiplied to a variable, and y is not being multiplied to another variable. Thank you very much, sir. Does that make sense so far, guys? So we know that a function is linear if the x and the y have a power of 1, if the x and the y are not being multiplied to another variable, and if the x and the y are in the numerator. Okay, now, what do these look like? What do linear functions look like? Well, the graph of a linear function will always be a straight line, my friends. It will not be curved. It will not be zigzagged. It won't be a bucket shape. No. It's always going to be a straight line. So therefore, in a way, this is great. Because if you're graphing a linear equation, and you know it's linear, the power of x is 1, the power of y is 1, they're both in the numerator, and you get something other than a straight line, no big deal, erase it, start over, you messed up. So, first of all, whenever you're reading a line, guys, you always read graphs just like a book, from left to right. Okay? So from left to right, this is a straight line. This is a positive slope. We'll talk about why that is later. That's a straight line. This is a vertical line, but it's straight. It's not curved. It's not peeking out. It's a linear. This right here, this is a straight horizontal line. It's not curved. It's not going up or down. That's a linear equation, function. This guy's going down from left to right, but there's no curves, there's no zigzags. It's a nice straight line. So these four lines are pretty much the way you're going to get a line. You're either going to get a line that's increasing from left to right. You're going to get a vertical line that's going up or down. You're going to get a horizontal line that's going from left to right. Or you're going to get a line that's going down from left to right. That's what a linear function is going to look like. If you don't get that, I'm sorry, guys, but you messed up. No big deal. At least you know. So if I gave you, for example, y equals 2x plus 5, and just real quick, you got something like that, you know you did it wrong. Okay, guys? Because remember, we're just recognizing today. We're not doing any real crazy work yet. We're just recognizing what a linear function is. Now, it is also possible to determine if a relation is a linear function by looking at a table and checking the first difference of both the x and y values. If the ratio of, by the way, this here is a triangle. That triangle is called delta, and delta means change. So if you take the ratio of the change in y over the change in x, okay, this has to be a constant for the whole set of given values. Then it will be a linear function. Let me explain why. Remember when we were talking about functions, I said that you can never have two different y's for the same x. Correct? Right, guys? Okay, hold on. Let me just make sure. Okay. So if I have here y equals whatever, 3x, okay? And I have my x and my y, and I go 1, 2, 3, 4, 5. And I go 3, 6, 9, 12, and 15. Am I not increasing by plus 3, plus 3? Okay. And from 9 to 12, I increase by 3. From 12 to 15, I increase by 3. For my x's, I increase by 1, I increase by 1, I increase by 1, I increase by 1. Now, these over here are the changes in y. These over here are the changes in x. What's 3 divided by 1? 3. What's 3 divided by 1? What's 3 divided by 1? What's 3 divided by 1? Do you see how there was a constant change here? The change in x divided by the change in y, or the change in y divided by the change in x, equaled 3 the whole time. It was constant. When you have a constant change like that in a table, you have a linear function. Yes, sir?
Is that change the delta?
Yes, that change is the delta. Good man. Thank you, sir. So, again, find the first difference of the x's and the first difference of the y's. How did I get from the first to the second? Then divide the change in y over the change in x for each change. If they're always equal, it is a linear function. What am I talking about? Examples are the best way. What did I do to 7 to get to 4? Subtract 3. From 4 to 1. From 1 to negative 2. From negative 2 to negative 5. From negative 5 to negative 14.
9.
Subtract 9. All right, now, how did I get from negative 1 to the negative 2 to negative 1? No, I did not subtract 1. I added 1. How did I get from negative 1 to 0? How did I get from 0 to 1? How did I get from 1 to 2? And how do I get from 2 to 5? Okay, now, please pay attention. Remember, we're looking, the constant has to be the y over the x must be constant. It has to be the same for every single change here. So what's negative 3 divided by 1? Negative 3. What's negative 3 divided by 1? What's negative 3 divided by 1? What's negative 3 divided by 1? What's negative 9 divided by 3? Are the changes of y over x constant? So yes, this is linear. Does that make sense, boys? You promise? All right. Let's find the first difference of x and the first difference of y. See if this is linear. How do I go from 6 to 3? How do I get from 3 to 2? How do I get from 2 to 3? How do I get from 3 to 6? How do I get from 6 to 11? How do I get from negative 2 to negative 1? How do I get from negative 1 to 0? How do I get from 0 to 1? How do I get from 1 to 2? How do I get from 2 to 9? Okay, remember, we must have the change in y divided by the changes in x must be constant. That means they have to be the same number. What's negative 3 divided by 1? What's negative 1 divided by 1? Negative 1. Wait a second. Are those two the same? So this is not linear. Very good. Does that make sense, boys? You promise me. Okay. Let's look over here and see. I gave it to you in a different format, but who cares? We can rewrite this. Remember, those are the x's, those are the y's. So let's go ahead and rewrite this. Sorry. Let's go ahead and rewrite this so that negative 5, 0. Oh, actually, wait. Let's go. It doesn't really matter. Negative 5. Actually, no, let's go in order. Negative 10, negative 5, 0, and 5. Then I got 10, I got 4, 2, and 0. Okay. How do I go from 10 to 4? Minus 6. How do I get from 4 to 2? How do I get from 2 to 0? Huh? Subtract 2. How do I get from negative 5, from negative 10 to negative 5? How do I get from negative 5 to 0? How do I get from 0 to 5? Okay. The change in y divided by the change in x must be constant. So I've got what's negative 6 divided by 5? That's negative 6/5, which equals negative 1 and 1/5. What's negative 2 divided by 5? Negative 2/5. Wait a second. Are those the change? Are those constant? So this is not linear. Last but not least, I got 2, 5, 8, and 11. And I got 4, 3, 2, and 1. What do I do to 4 to get to 3? Subtract 1. Good. How do I get from 3 to 2? Subtract 1. How do I get from 2 to 1? Subtract 1. How do I get from 2 to 3? Add 3. How do I get from 5 to 8? Add 3. How do I get from 8 to 11? Add 3. Okay? So now, let's check our y over x's. All of our y over x ratios must be constant for this to be linear. What's negative 1 divided by 3? Negative 1/3. Good. What's negative 1 divided by 3? Negative 1/3. What's negative 1 divided by 3? Are the changes constant? So this is linear. Does that make sense? Because this is really important, my friends. Recognizing is the first step before we go forward. Okay? Any questions on that so far? Okay. Let's move on. Okay, now, graphing functions. All right. Luckily, we already know how to graph functions. I taught you how to graph functions using the table method. One good news. This will be the last day that you will ever have to use a table for linear equations. I'm going to show you a trick here using the slope and the y-intercept, and I'm also going to show you a trick later using the x and y intercepts. But this will be the last day that you have to make a table for linear equations. After this, we're going to learn a little bit more advanced stuff. But let's just go over this because it's nice and easy and you've already done it. In order to graph a linear equation using the table method, number 1, always solve for y. You want to solve it so that it's y equals mx plus b. You want to get the y all alone. Number 2, use the moral 5 as your x values. If the coefficient of x is a fraction, use x values that are multiples of the denominators. Remember to always use 0 and opposite values such as 5 and negative 5. You always got to use 0 and you always have to use opposite values. That's it. That's how you graph it. We've done that. So let's see. Tell whether each function is linear. If so, graph the function. Okay, is this linear? A, y equals 3x minus 5. Yes, the y has an exponent of 1, and it's not being multiplied to a variable. The x has an exponent of 1, it's not being multiplied to a variable. Both the x and the y are in the numerator, so bingo, we're golden. Let's make a table. The coefficient of x is not a fraction, so I'm going to use the moral 5. Negative 2, negative 1, 0, 1, and 2. Hey, when x is negative 2, what's y? Negative 11. When x is negative 1, what's y? Negative 8. When x is 0, what's y? Excellent. When x is 1, what's y? Excellent. When x is 2, what's y? Come on, 3 times 2 is 6, minus 5 is 1. Excellent. Does that make sense? Does that make sense, guys? Awesome. Now let's graph it. Negative 2, negative 11. That's actually going to be way down here. Sorry. I actually only have up to 10. So we're going to have to estimate. Negative 2, 11 would be about here. Then we have negative 1, negative 8. Negative 1, negative 8. 0, negative 5. 1, 2, 3, 4, 5. 1, negative 2. And 2, 1. And that's it. It's a straight line. No zigzags, no U-shapes, no curves. You're done. Done. Okay? Next. Y equals x squared plus 2x plus 1. Is that linear? No. Why is it not linear?
Because X is power 1.
X has a power of 2. Very good. So this is not linear. We can make a table of values if we wanted to, but I said only graph the linear ones. So that would be not linear. Next, 5x plus 3y equals 9. First off, is that linear? Yes, it is linear. Very good. So now we got to solve for y. How do I solve for y here? No. How do I solve for y here? Thank you. This is a literal equation. You have to get y alone, my friends. Y must be alone. So I'm going to subtract 5x to both sides. And I have 3y equals negative 5x plus 9. I'm going to divide 3 to both sides. Please remember that that 3 gets divided to the negative 5 and the 9. So this will be left as negative 5/3 x plus 3. That is solving for y, guys. That is solving for y. Do you see the difference here? That is solving for y. Yes, sir?
You have done negative 5x plus 3 over 3.
No. 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 You cannot do negative 5x plus 3 over 3. No. No. Thank you very much. So now we're going to make a table. Now, am I going to use my moral 5 here? No, because I have a denominator of 3. So I'm going to use multiples of 3. So I'm going to use negative 6, negative 3, 0, 3, and 6. It's going to be nice and easy. Okay. When x is negative 6 times negative 5 is 30. 30 divided by 3 is 10, right? 10 plus 3 is 13. When x is negative 3, that's 15 divided by 3, which is 5. 5 plus 3 is 8. When x is 0, y is 3. When x is 3, you got negative 5 plus 3, which is negative 2. And when x is 6, you got negative 30 divided by 3 is negative 10. Negative 10 plus 3 is negative 7. I'm not going to graph this one because it's a little bit larger than my it's a little bit larger than my graph, but I'll graph all the other ones. So I got negative 3, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 0, 3. 3, negative 2. 1, 2, 3, 1, 2. And 6, negative 7. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Straight line, no bulges, no zigzags, no curves. You're golden. But you have to solve for y. Always. Does that make sense so far, boys? Now, here, y equals 5. I'm going to talk to you later about why this is. But when I have a y equals equation, does the x show up there at all? So that means my graph goes right through 5. 1, 2, 3, 4, 5. There's a horizontal line that's saying y equals 5 constantly, basically. But that is a linear function. It is a linear function. And we'll talk about why I did that. Okay? You with me so far, guys? Okay, just for giggles. If it was an x equals negative 3, does y get mentioned there at all? So when it's an x equals, it's going to be a vertical line right at x equals negative 3. Because that means that x is negative 3 constant forever. We're good? All right. Oh, is that it?
Yep.
Oh, well, that's it. Awesome. Well, then, okay, real quick then. Let me just make sure you guys got this, okay? Now, what if I tell you graph, I want to do one where you got to solve for y again. Let's say 2x minus 3y equals negative 6. Okay. What would I do here first to get y all by itself? Yes, sir. I saw your hand first. You're going to subtract 2x to both sides because you want to get y alone. And there's a two-step equation. 2x is being added to the y and negative 3 is being multiplied. to the y, so you get rid of addition subtraction first. I got negative 3y equals negative 2x minus 6. Now how do I solve for y here, gentlemen? Divide by negative 3. Very good to both sides. Very good. Please remember that when I have a division here, okay, I have to divide that value to everything in the numerator. So that goes up here and to here. So you leave this as a fraction. This is 2/3 x plus 2. And now it's Mickey Mouse time. Okay, let's make a little table. Am I going to use the moral 5 here? No, because I have a denominator. So I'm going to use multiples of that denominator. Negative 6, negative 3, 0, 3, and 6. Notice how I use the easiest, simplest multiples. I saw that on the last test. Some of you were using multiples like 18. 18 works. Yes, good job. I'm really proud of you. However, doesn't that make your life a little bit more difficult? Stick to the easy multiples is my opinion. Okay, when x is negative 6, you got negative 12 divided by 3, which is negative 4, plus 2 is negative 2. When x is negative 3, I got negative 6 over 3, which is negative 2, plus 2 is 0. When x is 0, y is 2. When x is 3, you got 6 over 3, which is 2, plus 2 is 4. And when x is 6, is 12 over 3, which is 4, plus 2 is 6. Now, if you guys can't do that math, I suggest you practice a lot, because what I did was not difficult. Remember that when you're plugging in to fractions, for example, when x is 6, okay? Remember that this 6 has a numerator of 1, denominator of 1. So it's numerator times numerator, denominator times denominator. So that's 12 over 3 plus 2. 12 over 3 is 4 plus 2. That's 6. So please remember that. Easy stuff, but it's easy to mess up as well. So negative 6, negative 2. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, negative 2. Negative 3, 0. 1, 2, 3, 0. 0, 2. 3, 4. 2, 3. 1, 2, 3, 4. And 6, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Straight line. No zigzags. No curves. You're golden. Any questions, my friends? Excellent. Thank you very much. I hope you learned a lot. Have a great day. All right.